Up until now, your classes and your execution code have lived inside the exact same file. In a professional application, every class blueprint should live inside its own dedicated module. By isolating your classes into separate files, your codebase remains easy to maintain and easy to read and find what you're looking for. Your main entry point file, in this case main.js, acts as a manager that imports the blueprints it needs, instantiates the objects, and sets them into motion. We also can separate helper functions like utility functions into separate modules and make them available anywhere we need them within our application. Let's take a look at a small example so that you can see what I mean. Here we have a project with a main.js file, which is where all the code we're going to execute is. We have a package.json file already in place, and you'll notice that I've set the type to module so that I can use ES modules. And then we have two directories, utils, which has a math.utils file, and right now it just has one function, getRandomInRange. It allows us to pass in a max number and a min if we want it to be something other than 0, and it gets us a random number. Notice this has already been set with an export keyword, so it's ready to be imported anywhere we need it. In the classes directory, right now we have just one class, wizard. Files that hold single classes should always be given the same name as the class, including using Pascal case instead of camel case for the naming convention. So notice here, I've imported getRandomInRange from my math.utils file, and I'm exporting my class. And not only am I exporting it, I'm exporting it as the default. That's going to affect the way that we import it in our main file. If you only have one thing like a full class definition to export, it is very common to just export it as the default so that you don't have to destructure it from an object. Just to familiarize ourselves with this class before we move back to main, it has a constructor that takes a name, it assigns that to the name property, and it also gives our wizard a starting magic points value of 50. We have a method castSpell that we can call at any time. It will use a random number between 5 and 15 to figure out how much magic has been used, decrease the magic points by that amount, and then return a string that gives us an update on exactly what just happened. When you're working with text adventure games, these sorts of strings are critical for being able to move the story along in an interesting way. So let's go back to main. We need to make use of wizard, and we also need to make use of our math.utils file here. Let's start by importing the wizard class. Now I mentioned that if you use export default, you can import wizard directly. Make sure that you put the .js on there, but I've given it the relative path to get to that file. Now let's import the randomization function. This one does need to be destructured because we only used the export keyword, and that's pretty common with a file where you might have multiple utility functions as your program grows. So we'll say getRandomInRange. Notice that VS Code picked up on what we were doing and filled out the rest. Now that we have access to our wizard class, we can create a player. So I'll say player is a new wizard, and we'll give him the name Merlin. Now we have a simulation of the game, but we have these null placeholders that we need to replace with the actual code we want to provide values. Here, I will go to the player and say player.name, and a troll appears, and if this were an interactive game, the player would be choosing one of these actions, and we're going to decide for him. We'll go to our player and call castSpell. Then we'll find out how much damage the troll takes, and we'll use our getRandomInRange function to calculate that. Let's do a range of 4 to 10. So max is 10, min is 4, and then we'll come out with a random integer. Then, if this were interactive, our player would be choosing this, and let's say he chooses to cast a spell again. Player.castSpell. And because the cast spell method in our wizard definition actually is also using randomization here, we should expect that the magic used is going to be different every time. And it's going to continue to decrease the magic points that are stored with the wizard. Let's run it. All right, Merlin enters the cave. A troll appears. Merlin casts a spell using 10 magic points. Points left, 40. The troll takes 4 damage. Merlin casts a spell using 14 magic points. Points left, 26. So this is a very small example, and you may have already picked up on the fact that there are some weaknesses here. If we were really trying to make this as modular as possible, there's a couple of things we could do. We could have a troll class or a monster class that allows us to pass in the type and call it a troll. And that troll could have a take damage method that we could call that would take care of this for us within that class definition. We could also have a function that handles letting the player choose an action every single time. And of course, this is just hard-coded, but if it was a truly interactive program, you would be using readline sync and validating and all of those things as well. But the main point here for now is just to show that this is a very common pattern for breaking up your code into multiple modules, putting all of the classes together, utility helper functions together, and so on, so that you can have a very straightforward sequence of the code that is actually meant to be executed. For your practice, you have a class, warrior, and you also have an app file. Your package.json file has already been provided for you, and it's set to ES modules. And here, you just need to import the warrior class, create a new warrior, and then call the method switch stance and print the return string. That's all I've got. I will see you in the next one.